Marten Spencer from Khombanani Steel. I'm the projects director for Khombanani Steel. The structure, it's a set of, there's 6 sites, and on those 6 sites we've got 13 bridges. It's all to do with the IRPTN Integrated Rapid Transport, which is basically BRT. The bridges are to get passengers from the sides of the road across to the centre where the BRT stations are in a safe manner. There are also lift shafts for disabled, so instead of having ramps up the sides, they've got the lift shafts on the sides of the road and the centre of the road. I think it's a very aesthetically pleasing design with 2 large lattice trusses made of circular hollow sections with a curved top chord, and the vertical members are also curved in elevation. The 2 lattice trusses lean out at an angle, so when you're walking down the bridge you get a good sense of space on the bridge. And then the bottom members, which support the floor, connect to the bottom chords of the main trusses. The main trusses we segmented into transportable sections because the lengths of the bridges ranged from 25 to 36 meters. So we cut them up into pieces that were transportable, so sub 20 meters. The 25-meter bridge had 1 splice. The 30 and 36-meter bridges had 2 splices along each of the side trusses. When we got to site, the side trusses were assembled into a jig. Everything was lined up and bolted together, and then the main cords, top and bottom cords on the 2 side trusses were site welded, and all the welds were then tested. One of the initial challenges we had was the grade of the circular hollow sections. The engineers wanted S355, which in the bigger bores, the 324 and the 356 diameters weren't available locally. So it put us under a lot of pressure once the material eventually did arrive to get the fabrication complete and through blasting and painting to site and all the pre-assemblies done so that we could meet our programs for lifting the bridges. All right, with the fabrication, we set up jigs inside our workshop and we pre-assembled and fabricated in situ the full side trusses of each and every one of the bridges. After doing that, we then did a complete 3-dimensional full assembly of the full length of the bridge to make sure that everything fitted together. After that, we broke it down into the transportable components and sent it off for blasting and painting. I think one of the great benefits of steel on this job is that the road closure was down to a limited few hours on a Sunday morning. So we'd manufacture, deliver to the painters, get the steelwork painted, delivered to site, pre-assembled in a jig until we had 100% complete pre-assembly. That was then painted with the final spec paint, and only then on a Sunday morning would we close the road from roughly 7 o'clock in the morning till 9 o'clock to do the lift. So it was very efficient, and the downtime from the roads department was very limited, thereby I think achieving what would have been very difficult with any other material. Proud of our involvement on a job which had a large scope, a large tonnage, a total of 13 bridges, 12 lift shafts, and with all of those bridges, all of them went together, fitted properly, perfectly on site, within 10 millimeter tolerance, and everything met that tolerance when it got to site.